So now we are going to tackle like the last section is about managing volumes and storage. And the first thing will be how to implement a local development workflow with Docker. And you might wonder what's the connection with storage and volumes, but it will quickly become apparent. So what we're going to do here is that we are going to share some data. Specifically, we are going to share a directory between the host and a container. The container will be our development environment, a little bit like the Fedora Dev VM that you have to work on a specific project, or if you're a Linux user, the Windows VM you have to work on a specific project. But we want to edit the code and work on the code using the tools that we have on our host environment. I have a title here too. So the code of the application that we are going to work on is on a GitHub repo. It's jpetazzo/namer. We don't know exactly what it is yet, but we will know soon enough. So I'm going to clone that here. So git clone git:/github.com/jpetazzo/namer. Okay. Now if I go into the namer directory, I have like a small amount of files. So I have a Docker file. We know this now. We have a Docker Compose YAML file. We are going to explain in maybe 10 minutes what this is about. We have a README. We have a gem file. If you've never seen one before, this is a usual suspect that tells us that this is probably Ruby, because gem files are used to declare the dependencies of Ruby applications. Then we have a .rb file, which like gives credit to the idea that this might be a Ruby application, and the .ru file. Okay, so we're going to look at the Docker file, and the Docker file is going to confirm that yes, indeed, this is using Ruby. It's copying the code in /src, then it's going to /src. It's executing bundler install, so that's the thing that's going to take the gem file and install all the things declared in the gem file. Then we say that the default command should be rackup --host 0000. Rackup is a small web application server. It comes with Sinatra, if I'm right. I don't know much about Ruby, so I hope you won't notice. But if you end up having Ruby questions, I'm not the best person to ask to. And then expose 9292, because Rackup default port is probably 9292, I suppose. Okay. Since we have a Docker file, we can build that app and run it. So I can do docker build -t namer dot. This is going to pull the Ruby image. It's going to take a minute. Then it's going to install the dependencies, which is also going to take a minute. And then it's going to give us a nice image. There we go. So we need to run it, and we need to expose its ports so that we can connect to it. So we are going to do docker run -d P namer. There we go. Where is it running? I mean, on which port can we connect to it? Wow, I have like 1 million containers again, and that makes me unhappy. So I'm going to like nuke a bunch of them. Let's get rid of that one, and also of that one, and also of that one. Okay, so namer is running, and it's listening on port 32770. So I'm going to connect to my machine on port 32770, and I get this. And if I hit reload, I get different names and also a motto: redefine plug and play e-services, drive vertical systems. Right, so this is an enterprise class carrier grade ISO compliant company name generator that also adds one line of bullshit below so that you can know what this company is doing. Not a very useful example, but it has high educational value, as we will see in a few minutes. So we want to do changes in the code because the customer who asked this is not happy with the color of the application. So we have multiple options here. The first option would be make some changes. So I edit the source code. Then I rebuild the image, and then I rerun the container. That would be the first straightforward option with all the things we've seen so far. The option number 2 is that I could use Docker exec, which I haven't covered yet, but Docker exec lets me drop into the container. It's a little bit as if I were doing SSH in the container. And once I'm in the container, I can install an editor and I can change files and restart things, and that would work, but that also not really clean. So the third option to have like the best of both worlds, so something that is kind of clean under approach but doesn't require to rebuild, rerun, etc., is that we are going to use a volume to associate, to mount a directory on the host to a directory in the container. Which directory? Well, the directory that contains the source code of the application. So since in the Docker file we copy the current directory to /src, so this is the mount that I want to create for my container. I want to say current directory, like home/namer. I want that to be mounted on /src in the container. Let's try that. So docker run -dp and then -v, like volume. And here I have to indicate a path on the host, colon, a path in the container. So the path on the host can be, I can give that like $home/namer, or I can use, like in the slides, I'm using like $pwd, but it's like whatever works. Colon /src and use image namer. Right? Now it's running, so let's look on which port. It's on port 32771. Right, let's go to port 32771. I have my application here. Wonderful. Now I'm going to make some changes in the application. So I'm from my EC2 machine. I'm going to fire up my preferred editor. Let's pretend it's VI. So VI company name generator.rb. And to make things relatively easy, we put like the CSS in the beginning. So if we need to change the color, it's here. I'm going to change the color here from royal blue to red. I save. I go to my web browser, I hit reload, and now it's red. So what happened really here is that when I changed files on my Docker machine, since that directory is mounted to the container, I ended up changing files in the container as well. I'm not expecting that you are deeply familiar with bind mounts because why? But bind mounts are a little bit like symbolic links, except they work on a different level on the machine. So when you create a bind mount, you tell to the Linux kernel, you do like mount -o bind this directory to that directory, and from that point, those two directories are going to be equivalent. Like the first directory is going to be mounted over the second one. So when you do changes in one directory, the changes are also visible in the other directory. And when I say changes are visible, that doesn't mean that there is synchronization or whatever. It just means that it's the same directory under the hood. So the directory /src in my container is the directory home namer on my host. Great, yeah.
Does that work also with NFS mounts?
Does that also work with NFS mounts? You mean if
The host has a
Right. If the host has an NFS mount, or if my home directory is on NFS or a USB stick or anything, yeah, it will work exactly the same way. Yeah. The this mount is on top of everything that already exists. So if my mount is on some fancy thing, that fancy thing is also going to be in that container.
You go back to that command that you did the volume mount.
Sure, absolutely. Let me show that in maybe here.
So the first half of that, after the dash V, that's inside the host, and after the colon, that's the local.
Exactly. Yeah. In the dash V option, it's path on the host, colon, path on the container. And that mimics the dash P option. If I want to map a port, it's dash P, port on the host, colon, port in the container.
So that's changing that container, but not that image. Is that correct? Or
That's right. This is changing the container, but not the image. The image is not changed by that. If we look at the mount namespace of that container, I still have my image and I still have /src in that image, but over /src I have mounted something else. If I had the sufficient level of privilege and credentials, etc., once this container is running, I could unmount /src and then it would reveal what's in the image. Just like when you mount like a USB stick on top of a directory, that directory is kind of masked by this mount. Okay. And you can obviously make changes both ways. So for instance, we could have something in the container like spitting out log files or traces or whatever, and these would show up on the host as well.